In this video, you are going to learn how to convert between particles and grams. We've already learned how to convert between particles and moles. To convert between particles and moles, we've been using Avogadro's number. That's 6.022 times 10 to the 23rd. Particles are equal to 1 mole. They're in 1 mole. And you've learned how to convert between grams and moles. We have used molar mass because that is the number of grams per 1 mole. Depending on the atoms, depending on the elements, it'll have a different molar mass. So now, the question is, how do we convert between particles and grams? Well, notice, both of these conversions that we've already learned have moles. So what we're going to be doing is we're going to take our particles, and we will convert them into moles first, and then we will convert from moles into grams. Okay, or if we're starting with grams, we will take our grams and we will convert from grams into moles, and then from moles into particles. Okay, so when we convert in the first one, when we convert from particles to moles, we'll be using Avogadro's number, and when we convert from moles to grams, we'll be using our molar mass. And the opposite goes for our second one. When we start with grams, we will start with molar mass. We'll start by converting from grams into moles using molar mass, and then we will use Avogadro's number to convert from moles to particles. Let's try an example. So how many atoms are in 45 grams of nickel? Okay, so our unknown is our atoms. This is a particle. That's what we want to figure out. We want to figure out how many particles we have, and our given is our 45 grams of nickel. So just like all of the previous problems, we always start with our givens. That's 45 grams of nickel. Okay, we can't convert from grams directly into atoms, though. We only know how to convert from grams into moles. So we're going from grams into moles. Okay, and in order to get from grams into moles, we need to use molar mass. So the molar mass of nickel, looking at the periodic table, is 58.71. That means there are 58.71 grams of nickel in 1 mole. Well, I'm starting with grams, so I want my grams to cancel, so grams is going to go on the bottom, and I'm converting it into moles. So in 1 mole, there is 58.71 grams of nickel. Okay, so now my grams cancel out, and I am left with moles right now. But I do not want to end up with moles. I want to convert from moles into atoms. Okay, so in order to get from moles to atoms, I'm using Avogadro's number, because there are 6.02 times 10 to the 23rd atoms, or particles, in 1 mole. Okay, so I draw my multiplication sign in a line, and I want to get rid of moles. Okay, moles is on top, so I need to cancel it out, so I put it on bottom. And I want to end up with atoms, so atoms is going to go on top. Okay, so in 1 mole, there are 6.02 times 10 to the 23rd atoms of nickel. And notice, now my moles cancel out, and I'm left with atoms, which matches my unknown, which matches what I want to figure out. So now, all I'm doing is plugging this into my calculator to get the answer. So it's 45 times 1 divided by 58.71 times 6.02 times 10 to the 23rd divided by 1, which equals 4.61 times 10 to the 23rd atoms. So if I had 45 grams of nickel in my hand, I would be holding 4.61 times 10 to the 23rd atoms of nickel. What is the mass of 4.59 times 10 to the 23rd molecules of aluminum fluoride? So in this problem, the question is, what is the mass? So remember, mass is in grams, so I'm looking for my grams. and I'm given 4.59 times 10 to the 23rd molecules. So this time I'm given particles, I'm given molecules, and I want to end up with grams, but I can't convert them directly. Grams are mass. I can't convert directly. I have to go through the mole. Okay, because I know how to convert from particles to moles. I know how to convert from moles to grams, but there's no direct link between particles and grams. So I start with what I'm given. That's my 4.59 times 10 to the 23rd molecules. And I'm going to convert it into moles. So molecules goes on bottom because I want to cancel out my molecules. And moles goes on top. And there's 1 mole for every 6.02 times 10 to the 23rd molecules of aluminum fluoride. And now I'm converting it into grams and doing my next step. So mole goes on bottom, so my moles cancel out, and grams will go on top. So there's going to be 1 mole, and remember, to get from moles to grams, we look at molar mass. So on your periodic table, you need to find aluminum and fluorine and calculate its molar mass, which is 83.98, and then you just multiply across and divide by your denominators. And you should get You should get 64.03 grams, we're left with grams, of aluminum fluoride as your final answer. So if I had 4.59 times 10 to the 23rd molecules of aluminum fluoride, that would have a mass of 64.03 grams.